The whispers in the morning.
Today in this video, I will be teaching you how to analyze a double salt ammonium ion 2 tetraoxosulfate 6-hexahydrate, the salt over here. You will be required to, you might be told to collect small solid sample of C, or they might call it E, whichever letter, and put small sample of it in a boiling tube like this. I'm collecting a small solid sample of it. Put it in a boiling tube this way. Yeah, you might be told now to add few drops of sodium hydroxide, then you heat or warm. So what I'll do now is add few drops of sodium hydroxide and warm. Then if you are warming this particular salt with sodium hydroxide, it is expected that it will give you ammonia gas. And what are the features of ammonia gas? Ammonia gas have a choking smell, irritating smell, and is an alkaline gas. It turns moist red litmus paper blue, or it will form white dense fumes when you dip glass rod in HCl and hold in the mouth of this. So when I add sodium hydroxide now and heat gently, I will either use my litmus paper, this is the red litmus paper moist, and hold it at the mouth. It will turn the red litmus paper blue, and I can also waft the gas. You do wafting. Remember, you don't smell direct, you waft. When you waft, you take note of the gas. It will have a choking smell. It will have an irritating smell. Some may say it smells like urine. Of course, it might smell like urine. Such gas is called ammonia gas. And the only salt that will liberate ammonia gas when you heat it with a base is an ammonium salt. So let's go with this step. I'm going to add my soda hydroxide. I need a dropper, but I couldn't bring it. I don't want to go wasting time. I can gently drop small. Even without dissolving it in water, you might be told to do this small and then warm. Even here, if you are asked to do this, you see what you can report. There is formation of green gelatinous or dirty green gelatinous precipitate when you add the sodium hydroxide. Yes, you can use this one test and confirm two ions. They can use one stone to kill two birds. You can see it gave us a dirty green gelatinous precipitate on adding the sodium hydroxide. So then, warming gently, I might apply the two steps. I'm going to moisten my red litmus paper and also dip the glass rod. Over here I have the water here. Just want to dip it inside. Remember, no gas is acidic or basic without water. So if I use this litmus without moistening it and hold it here, it can never change color, because the water is needed to protonate the medium or to produce the hydrogen ion or the hydroxyl ion for the gas to form either an acid or a base. So the ammonia gas alone without the OH from water will not have effect here. That's why I'm moistening this. So I'm answering some conic questions that you might be asked during practical chemistry. Why must litmus paper be moist before using it to test for gas? Because no gas is acidic or basic without water. That's why if you dry gases, they have no effect on litmus. So I've moistened this litmus and I'll keep it aside before starting my heating. I'll have to open this so that it will be easy for me. Insert my glass rod, this HCl dilute of course. Then I will start this gently. Sort of it. You set it well to be non-luminous. Okay. Then, guess I'm good to go. I'll use this first one first, holding it at the mouth. Let's see what it does. See, the gas is coming. It has turned it blue. Then with this, okay, yes, I think it's clearer here now. There is a fume. See the white dense fumes going with glass rod dipped in HCl. This result will be more obvious if you use concentrated HCl. Here the gas turned moist red litmus paper blue. So what happened here, I've explained the chemistry, but let me kind of recap what I said. I add sodium hydroxide. There was two things I can report here. There was formation of dirty green gelatinous precipitate when we added the sodium hydroxide. Then on heating, it liberated colorless gas with a choking smell which turned moist red litmus paper blue, as you saw. Then, or that formed white dense fumes with a glass rod dipped in HCl. Then this means that this is ammonium ion. So you can also say ion 2 ion, likely in this case. So you might be told to add few drops of sodium hydroxide direct and heat and allow. When you are told to keep it for some minutes, you report what is happening here. You say the dirty green precipitate, the dirty green gelatinous precipitate turned reddish brown, and you have to confirm both ammonium ion and ion 2 ion. You might be told to put a half spatula in a boiling tube or in a beaker and add about 5 cm cube of distilled water, then stir well to dissolve, then test with litmus. Now the next step might be add about half spatula of C in a boiling tube or in a test tube or in a beaker, and then add about 5 cm cube of distilled water. In this case, you are not going to be measuring the water, just add what you can divide into 2 or 3 if the instruction says divide into 3. Use your discretion. So I'm dissolving it. You see, on the solution it's giving me a light yellow or slight greenish solution. This is about kind of a yellowish, just pale yellow solution, of course. That is or you say light green solution formed. You now report that C is soluble in water. This has dissolved, or giving us a light green, a pale yellow solution, yellowish. It's not all that clear. So maybe I'll be dividing into 3 portions. So let me add more. Then, but before you divide, you'll be told to test the solution with a litmus. If you are told to test with litmus, nobody tells you to use blue or use red. You use both of them and see the one that have effect. If any solution have effect on red, it means automatically it will have no effect on blue. So what you do now is you bring your red litmus paper. I'm trying to check the hydrolysis now, salt hydrolysis. What happens in aqueous solution? See the red. Bring this a bit closer. Okay. For now, it's not really affecting the color of the litmus. It has no effect on this red. No. So it's not affecting red at all. So I'll check blue. I'm going to check blue litmus. I've used red, no action, no color change. So now let me use blue. This is my blue litmus. Here I go. See? Oh, sorry about that. So it has turned the blue red. So your report is that the solution is soluble, dissolved to form pale yellow solution. A pale yellow solution is formed. C is soluble, then the solution turned blue litmus paper red. That means solution of sample C is acidic. So solution of this ammonium ion 2 tetrahydrosulfate 6 hexahydrate is acidic because of hydrolysis. So if they tell you why do normal salts in aqueous solution affect the color of litmus, reason because of salt hydrolysis. That's the interaction between the cations and the anions of the salt with water, with the hydrogen and the hydroxyl ion of water. Now, from the instruction we are given, we are told to divide into 3 or 2. I'm dividing into 3 this time around, just to test for the reducing. So this is the first portion. Sorry about this, the second portion. Then I keep this as my stock. Now, to test for sulfate 6 ion, you need barium chloride and this barium chloride, and equally together with hydrochloric acid. So these two, this is my barium chloride, this is my hydrochloric acid. These two pairs of reagents are used to test for the presence of tetraoxosulfate 6 ion, trioxosulfate 4 ion, then trioxocarbonate 4 ion, that is SO4 2 minus, SO3 2 minus, or CO3 2 minus. They are used to detect their presence. Then the HCl is what confirms which one is present among these three, but the barium chloride is used to detect the presence of these three. This ideology is because barium sulfate is insoluble, barium sulfite, that is BaSO3, is also insoluble, and barium carbonate is also insoluble. That's why precipitate will form if any of these three are present in this solution. But among these three things is only barium sulfate that will not dissolve in acid. But barium carbonate, just like every other carbonate, dissolves in acid with effervescent liberating CO2, colorless, odorless gas, which will turn lime water milky. Then barium sulfite, that's BSO3, also dissolves in acid to give you a gas with a irritating smell like that of burning matches, that is liberating SO2. So if the precipitate that will be formed now, I want to add my barium chloride solution.
So everybody, if you are watching this video right now, go and subscribe if you haven't subscribed. And if you're a subscriber, please stay subscribed for more updates you get from Samaje's Easyword Science channel. Thank you. Bye.
Hi, I'm Dr. Kingsley. I'm the product of Samaje's Easyword. Join Samaje's Easyword today and be proud of what your tomorrow will be. Much love and remain majestic. Thank you.
You need a dropper, you add it. Just when they tell you add barium, no need of telling you drops or in excess. You see, just add the barium. There is a white powdery precipitate or white chalky precipitate. This is indicating the presence of tetraoxosulfate 6 ion, trioxosulfate 6 ion, or trioxocarbonate 4 ion. Tetraoxosulfate 6 ion, trioxocarbonate 4 ion, or trioxosulfate 4 ion also. So now, adding excess hydrochloric acid is to check if the precipitate is dissolving or persisting. The precipitate remains as it is in the beginning, so this automatically shows that this is SO4 2 minus. So in the ammonium, in the sample C I'm analyzing, or whatever letter you might use for the sample, it shows that there is presence of tetraoxosulfate 6 ion because it persisted in acid. This is for the first portion. Remember, I'm giving you this guide and tips on how to analyze this. If you go into the exam, or if anyone tried to give you exam on this salt sample, you listen, or rather, you read the questions very well on the question paper and follow the instructions. Do the first thing they ask you to do first. So this is it for the first portion. Then the second portion, you might be told to add sodium hydroxide in drops and in excess, then and heat. You see, this time around they are using the same one stone to kill two birds. So you might be told to add sodium hydroxide to the second portion in drops until in excess, then heat or warm. You see, this is in drops, that is dirty green gelatinous precipitate. It is sticky to the walls of the test tube. It's forming a gel. Then in excess, it is still forming more of the precipitate and is persisting. See, the precipitate is persisting and you'll be told to warm. So in this thing, we have done the heating before. I'll still heat again, please. But on warming, to save time, there will still be evolution of a colorless gas with a choking smell, which will turn moist red litmus pepper blue and form automatically white dense film with glass rod dipped in hydrochloric acid. It's the same thing. Then on heating, after heating, you'll be told to keep for some minutes. So when you keep this for some minutes, it will turn from dirty green to reddish brown or brown precipitate, and that confirms the oxidation is happening already. That confirms the oxidation of ion 2 to ion 3. Oxidation of ion 2 to ion 3. Okay. So on heating, we have to get our litmus paper ready, which is here. You moisten it in water, then you heat. Oh yeah, you see the mouth, you see the turning is slight. Then you'll be told to keep this. So when you keep it for some minutes, it will turn reddish brown, and it has happened at the same time, you see. So in your observation, you say on adding in drops a dirty green gelatinous precipitate formed, then in excess the precipitate remain insoluble. Then on heating, you report that a colorless gas with a choking smell which turned moist red litmus paper blue evolved, or say which formed a dense white fumes with dilute HCl or equally con HCl. That is it. Then your inference, you are going to tell us ion 2 likely, then ammonium ion, ammonia gas from ammonium ion. Remember, for the table, the detailed table and the well-organized questions, you also join my live stream. And for your titrations, especially the iodometric titrations, the redox titration between potassium to sulfate, or rather sodium to sulfate, sorry, the titration between sodium to sulfate and iodine solution dissolved in potassium iodide. For the appropriate and the accurate endpoints, I know I've done this titration with 0.1 mole per dm cube and 0.1 mole per dm cube of each of these reagents. When you make the other one the titrant, you might not get a neutralization, and the endpoint is quite confusing. So join my live stream, let me tell you exactly what we are expecting in that type of titration. And you can also check other videos. I'm giving you this, the weights. I'm keeping this for a while and see what happens. And you see the reaction is obvious. You see the precipitate has turned reddish brown. I don't know if my camera can capture it. This is green here, and it's already turning reddish brown. Let me bring it closer to the camera. Okay. You see the reddish brown color here, it has been dirty green. So on keeping, on exposure, or on standing, the dirty green precipitate turned reddish brown, and you write in your inference ion 2 confirmed, because the only thing that would be dirty green or green precipitate that will later turn brown or reddish brown is ion 2 ion. The turning is due to the atmospheric oxidation of this ion 2 to ion 3. There is oxygen that's reacted with this ion 2 and is making it now ion 3, and the color of ion 3 is either yellow or brown or reddish brown. So that is the process here, and you are done with what they want you to do. In the other case, we might also be told to add potassium heptaoxodichromate 6 to a third portion. Let's see what it will do if we happen to do that. This is the ion 2, the acidified K2Cl2O7 potassium heptaoxodichromate 6 is here, which is orange. And remember, the ion 2 here is a reducing agent, of course, because since it can be oxidized to ion 3, it means it will reduce something to get itself oxidized. So it's going to reduce this from the chromate 6 ion to chromium 3 ion, and the color will change from orange to green. Here we are adding, okay, you see automatically it turned. You see exactly what happened here. It turned on adding acidified K2Cl2O7 solution C, or whatever you call it. That's the third portion now turned orange color of acidified Cl2O7 from orange to green. And in your observation, you just say orange color of K2Cl2O7 turned green. In your inference, C or whatever is a reducing agent or presence of reducing agent. And I advise maybe don't use suspected again. In this case, I think maybe some example have ruled out suspect. Maybe they believe that ions are not criminals that you suspect. You can say present or likely, or you use confirmed. So you say reducing agent present, or C is a reducing agent. It's obvious that it's a reducing agent for turning this acidified K2Cl2O7 from orange to green, and that's because of the ion 2 that is present. This is more reason why you buy from the Easyword, because if you buy the one that the majority of the ion 2 has been oxidized to ion 3, my dear, this result might not take place well. And some of you might add this, it will not change. So you have seen the possibilities here on the analysis of ammonium ion 2 tetraoxosulfate 6-hexahydrate. The academic success is my priority, but our application of science principles in terms of practicals is my topmost priority. I so much love you and I value you being around this channel. Expand this community. Much love from me to you. I cannot do without you. Place order for your reagents and apparatus. God bless you. See you. Bye for now. I love you.
Hi, my name is Cheryl and I'm Jennifer. Guess what? There's a channel called Easyword Science.
And you know the best part? It makes science so easy. Wow.
It makes science easy, simplified, and very, very fun.
Guess what? Rocket science ain't rocket science anymore.
It's now ABC.
Like if you did science your entire life.
Another thing about Easyword Science channel is that he makes available laboratory equipment and reagents.
Guess the best part? If chemistry has been hard for you, he does tutorials.
And another thing is, when you order for these things, they are high quality and they are also cheap and affordable for anybody.
If you want to order, just look at the number below the screen.
And don't forget to subscribe and hit the little notification button down below.
Don't forget to share, of course. Obviously, there's love in sharing.
Thank you. See you there.
For accurate results and proper guidance, buy from the Easyword of Science. You have your iodine crystal here. All those specimens, the materials needed are available and they are affordable, then reliable. Here is your potassium iodide, pure, which is used to dissolve iodine. Then here you have your well-prepared starch indicator, which is effective in the titration. For any challenge concerning this titration, you contact Her Majesty Easyword. If you buy from us, you have your 15% discount and have more access to our services, of course. So you see the indicator is effective. You drop it into the iodometric redox titration. It has turned blue-black, which means at end point it will become completely decolorized. This type of titration comes with a lot of challenges. Contact me for further guidance, of course. But here I'm telling you what is available for you to have your accurate result and make yourself successful in analysis. Here we have our sodium thiosulfate, the pentahydrate form of it, purified with the highest purity you can get, and the reliable results are available. Here you have the ammonium ion 2 tetraoxosulfate 6-hexahydrate, a double salt. Then here you have your barium chloride. The barium chloride, which will be automatically used in analysis, often used. And here you have your volumetric flask for preparing standard solutions, especially preparing solutions A and B. They are all available, they are affordable and reliable. Here is the burette of different types. You have the one with a tap, the one with clip, the one with ball. Place your order now at easywordscience.com, or right here you're watching this video. You contact me with the number +234 7065166217. These are the boiling tubes plus other things, and here are the pipettes, the volumetric pipette or the bulb pipette for accurate volume measurement. The measurements and the precisions are high. The Easyword Science channel is here for you. Your success is my utmost priority. Here is the wash bottle. Their prices are very friendly and they give you the best service you want. Over here we have our weighing balance, analytical balance, which is very much sensitive. It can weigh 0.01, like when you are required to measure 24.82, this particular one can do it. And here is our beam balance, the triple beam balance. It takes more time, but this can last for 30 years for you, of course. This is used based on the principle of moments. Then other reagents you want and other apparatus are available for you.
Name them all, as you can see there on the screen. We have all this, we supply them. So contact us at easywordscience.com or Some Majesty Easyword Science channel on YouTube, or you can contact me with the line you see there on the screen. You can email us with easywordscience@gmail.com. God bless you, patronize us. We will help you in setting your laboratory also, in chemistry, physics, biology, and even your hospital equipment. Auto analyzers are available at the Easy World of Science. We cannot do without you. We value your patronage. Much love from me to you. See you.
I love you. Thank you for watching.